All right, so when it comes to imaginary numbers, it's always helpful to remember where they come from. Where an imaginary this imaginary unit that we call I, it is representing the square root of -1. So that means that this number does not exist as part of the real numbers. We know that there's no number we can multiply times itself to get a negative number, so we use I instead. We also use some other powers of I. The most important one is the one you see here. I squared is the same as -1. This one's very important because when we perform any operation with imaginary numbers, we treat I as if it were a variable. Let me just write that. Treat I like a variable unless it's squared or cubed or any other exponent. All right? So we treat I like it's a variable. It's a like term we can combine. But imaginary numbers have this tricky feature is that when we multiply them times one another, we go back and forth between real numbers and imaginary numbers. Because we will work with these in a little bit, we can make sense that I to the third is a -I, and I to the fourth is +1. We can multiply different versions of I together to make sense of that. But where we really use those powers of I is if we were simplifying something like I to the 31st. So if we look again at this cycle of I's, we can see that once we get to our fourth power, we get to number 1. And we know that anything times itself, anything times 1, we get itself. So I to the 5th is really 1 times I. So this whole cycle starts again. Once we have I to the 1st here, we get I to the 2nd, 3rd, 4th, 5th would come up here, 6, 7, 8, 9, 10, 11, 12, and so on. So what we want to do is we really need to figure out where does I to the 31st fit in. Well, we can divide that 31 by 4, and the remainder of this division will tell us where, what power of I our expression represents. So if I were to long divide here, this will go quick. 4 goes into 31 7 times, 28, and 3 is our remainder. Because 3 is our remainder, that means we have a value equivalent to I to the 3rd. So I to the 31st can be simplified down just to -I. Let's look at one more problem just to see what else can happen here. I have a simplify problem. This is a problem where we are going to get rid of the square root in our denominator, remembering that I is a square root. The way we do this is we multiply by the complex conjugate of that denominator. By multiplying by the complex conjugate, a number that has the same values, except with a sign difference between them, we will get rid of our imaginary numbers in our denominator. We also need to multiply our numerator because we can't change the value of the fraction. So I'm going to work on the numerator first here. I'm going to just distribute this out. I'm going to get 8 minus 8i minus 12i plus 12i squared. We will simplify that in a moment. And then in the denominator, we have 16 minus 16i plus 16i minus 16i squared. So remember earlier, we treat these i's as if they're a variable unless they have a higher power. So I can combine -8 and -12i into -20i. 12i squared is the same as -12. So -12 and 8 will lead us to -4 as part of our numerator. Now, this is really why we do this. In the denominator, our imaginary numbers will cancel. And -16i squared is the same as +16, so our denominator is 32. We can simplify this down. because all three terms are divisible by the same quantity. They're all divisible by 4. So there is our fully simplified imaginary.